Okay, I guess we're ready to start. So yeah, Ketil and I, we're working in the ARM's MPG division, so we work on the Mali GPU drivers. Used to work on the Mali 400 and all the drivers, so what's in the high key. But the last 7 years, and you've been the last 5 years working on the Midgar and the Utgar generation. So our experience with Mali 400 is a bit rusty, but we can still ask questions about that. So first, we're gonna start. Okay, standing in front of the. Give some updates about some new stuff that's happening in the Mali ecosystem. So we've just released a Vulkan SDK. It's an MIT license. You can find it on GitHub. It was released at GDC, so you can experiment with it, use it to play around and learn a little bit about Vulkan. You can even use it in commercial products because it's permitted. So yeah, please do. And you can visit that web page to see a little bit about like typical use cases. I think there are a few examples using it, and you can take it from there basically to start experimenting with Vulkan. Because I know that there's a great demand for actually learning how to use Vulkan as an API, because it seems like unless you're using one of those big game engines, you don't know actually how to use Vulkan in an optimized way. So this is a good starting point. Okay, so the Vulkan is supported on the Bifrost GPUs and the Midgar GPUs, but not on the Utgar GPUs. So the high keyboard won't support Vulkan because it's a Glass 2 only SoC. So next up, it's not released yet, but it's going to be released by the end of this month or early next month. It's the ARM Compute Library. It's a set of functions you can use in your program, and it has a backend for both running on the GPU using OpenCL, but also to run on the host CPU using Neon Intrinsics. And it allows you to do, as it lists here, a lot of fun stuff that's useful for, say, recognizing, say, people in a picture and like recognizing objects in general. So it's something, and there's actually not a link I can provide you that's going to fit onto this web page. So if you go to community.arm.com and search for it, it's much easier than to actually try to have a very long link. And the plan is to release it on GitHub on ARM's software page, but it's not there or not there yet. So that's the latest news from Mali. That was a short session. So mainly this session was supposed to be a Q&A, and I know some of our friends have some questions that he's going to repeat from the last Connect.
Perhaps a follow-up question is, are you going to have to answer the same questions at the next Connect?
Well, so the current situation for us is that we're not going to open source the user space drivers because there's a risk-gain evaluation, and right now the risk of patent trolls is too great, basically, versus what the gain would be.
You are afraid that you broke some patents and don't want to tell.
Okay, I'm a software engineer.
Yeah.
So our problem is that we don't suspect that we have broken any patents, but the problem with patent trolls is they're going to go after ARM, and ARM's going to be needing to defend ourselves, and we're going to spend a lot of dollars. And if we win, / when we win, there's no money to be gained. As in, there's no damages or anything that we can reclaim from like the patent trolls, because they basically have no money and nothing we can go after. And they have nothing to lose, basically. So happy with that answer still? So I started with say why we're not open sourcing the user space drivers.
Does that satisfy your sensibilities? Is that the question you like to ask?
Basically, I knew the answer before I came.
But he still keeps asking.
I just wanted to check, this answer got changed?
Yeah. So, and to answer your follow-up question was, will it change before the next Connect? As I said, it's a continuous evaluation between the risk and gain, so I can't promise anything.
Would it be fair to say that the risk for a Vulkan-based driver is lower than the risk for an OpenGL driver because there's less that you do in the driver?
Well, I'm not a lawyer or anything, but I would assume a Vulkan driver is less risky, but yeah. As I said, I'm no lawyer, so I'm not going to go into that area.
No, but that's something, I mean, pushing for a Vulkan driver at this point might make more sense than pushing for an open source
Yeah, so I agree. So Vulkan is the future, and if the lawyers agree that a Vulkan driver is less risky, it might be something that's going to sway them towards the gain is higher than the risk. So maybe that's the answer to what happens before the next connect.
The good part is that Mali is only 3G.
Yeah.
We can still live with this.
But remember, Mali is also display and video encode decode. So if you ask for the other drivers, like the Mali display, it's in mainline, it's fully supported. And we're working on maybe open sourcing stuff for the Mali video hardware as well. So yeah, maybe that's going to be a good answer for next connect.
We finally have device tree bindings for the GPU. Right?
Yeah, there's some device tree bindings posted for the old Mali drivers, and there's also plans for actually making proper device tree bindings for the Midgard/Bifrost generation of GPUs.
Which I think is actually more progress than we've had in the last few years.
Yeah. So the problem we have there is that a lot of the vendors have extended what they consider device tree because they see it as yet another way to integrate their custom stuff. So normally when we find SoCs, they have modified the device tree bindings by adding new stuff that they need internally in their integration of the drivers, like special stuff to integrate into the other IP, and then you pass handles through the device tree and things like that.
This is basically what happened here. So so far, we've never taken the device tree bindings because we said, well, there's no kernel driver. And then, of course, every SoC vendor came up with their own device tree bindings doing the same things in a somewhat different way. And people complained, like, why are they all using those non-upstream device tree bindings? Well, there are no upstream bindings.
I agree. So
we have to get there some way, one step at a time.
Because we have provided like documentation with device tree bindings as if it was upstream to our customers, but they haven't treated it as a fixed contract.
Right, but
basically.
from the kernel perspective, whatever you publish has no impact whatsoever on what we do in the kernel.
Yeah, I agree.
Once it's in the kernel, that's actually the official.
No.
And hopefully that matches what you have. I don't know.
Yeah. No, so what we plan is to actually work with maybe, because I have like at the previous Connect and at Plumbers we talked about maybe opening up the potential for the kernel to accept device tree bindings for some driver which isn't actually in mainline, just to basically as a starting point actually maybe in the future to merge it into mainline if we get an open source user base.
More for the audience, because I already talked with you a little bit about this. So something that's been a huge pain point over the last little time period is trying to run Mali against mainline kernels. Is there anything that you want to tell or say that might improve the situation in the future?
Yeah, so internally in ARM we work on actually fixing issues. It's the delay of releases and all of that which actually postponed when you actually get access. And like our problem is that our commercial interests are normally on older kernels because like they ship Android devices with 3.18 and 4.1 and 4.4, and that's what we actually need to focus on because that's what we get actually paying customers asking us for. I know. But like internally in ARM, like engineers actually fix mainline kernel issues because we actually use mainline kernels internally when we are developing. So we actually try to fix it, but we're talking about months and months before actually the latest code we were writing actually is published. So that's a problem, and it's not easy for us to actually provide patches to already released code.
Push something for ARM, yes. It's easier to report inside of ARM than get it from ARM.
It's easier to fix it yourself almost. I mean, it's one of those, it's great that you guys are keeping stuff up yourself, but
yeah, but as I have discussed with you, I have been proposing within ARM changes on how we do like kernel drivers, deliveries and things like that. But
it leaves a really bad taste in your mouth when you have to do this over and over. It's.
So, question for you, John. Do you think that there might be a scenario where you could perhaps partner with someone in the open community to do a user space implementation of just, say, Vulkan, that would then use your kernel driver, and then, you know, you guys have the good professional stuff that, you know, has its space, but then likewise we have something that satisfies the needs of the open community as well?
So I can't answer for ARM's commercials interested into this area, because like ARM do sell a driver that's it's going to compete with. So I guess the answer would be no. So any other questions related to that, or?
Do you have any suggestions, I guess, how to, what would have a big enough impact that would change the beliefs internally?
Well, I wouldn't know that, because like it's money basically that's dictating everything.
How
Yeah, so if customers made demands actually to change all of this, maybe.
So yeah, just I've been packaging the existing non-free drivers just so that at least you could apt-get them, and yeah, got as far as discovering that the bindings aren't in the kernel, so actually nothing works, and we really need to fix that. And I guess I should talk to some people about how we unblock this thing, so at least we could have that part fixed.
So about making like apt-gettable drivers seems trivial, but we need to create, say, drivers not per board, but per GPU revision, actually,
Yeah,
because
your-
you
your-
compile the
your
binaries to actually match exactly
build
how many
system-
cores you have and all of that. So
The
it's not
build
like
system
one binary.
mitigates against this because it's designed exactly backwards from the point of view of binary distros. But
Yeah.
yes, at least we can support a few things if we had some bindings.
Yeah, so if like there were popular boards and things like that, we could actually probably set up a way to get easy access
That's
to
the
the
plan.
binaries for that.
Exactly. So at least if we can get some things working, that would improve people's lives a bit. But we have to
Yeah.
fix the DTS problem for that to actually work.
I heard of some ideas of getting Turbo into running Mali-Java into the latest kernel. I might be doing similar thing for a new device, so I'm wondering if there are application notes from ARM's side or whatever. You can gathering all those inputs, and this can be handled to another guy who will be doing the similar stuff, so make his life much easier.
Yeah, so like when you like do like receive drivers from ARM, you get the full release notes and integration notes, and everything should be included. And there's a channel to give feedback if you encounter problems or issues, so it can be improved or changed anyway. So that document should already include information on how to feedback on improving the documentation.
Yeah, so you already have some documentation, but for example, the documentation already included John's feedback, his experience. I assume there's still some kind of traps
Yeah, okay.
he experienced, and what I'm saying, I'm trying to get his experience into your documentation so I can get rid of, overcome the difficulty I have to go through again. So
I think the complication is who the agreements are with, because I don't think I have an agreement. It's like I'm just using a board that I have, and the software that was available publicly didn't work, so I've just got to fix it because I'm not a vendor selling the hardware. You know, I don't have the licenses for those things, so it's just one of those things where the pain is that this, you know, there are people who I guess are supposed to be responsible for making this nice, but they're not, so I've got to do it, and it's being outside of this cycle for this is just dysfunctional.
I'm not sure if there are any like IRC channel mail list we can kind of watch
Okay, so
all those informations.
I don't think, so the problem is that ARM focuses on like direct licensees, and they get all the information and all of that, but Linaro is not a paying customer of ARM, so.
Okay.
Yeah, so we have received feedback from Linaro and have tried to incorporate it.
But-
It's just that,
Also from others.
yeah.
But Linaro is also, we don't work just by ourselves, we work with our customer, like for example, High Silicon, so they kind of had agreement with
Yeah, so,
ARM.
so High Silicon has direct channels, like pretty good direct channels to engineers even, so they can give feedback.
So
easily.
usually we have to go through High Silicon back to ARM, and always go this way, right?
It's- Yeah, so maybe that's the channel for Linaro and other non-customers to actually give feedback.
/that/no always works.
that even you could apply just to result in a bench from lots of customers.
So, because I mean, having made some packages, I realised that I needed a way to find out when new releases were, just so that things would actually be kept up to date. So we have people on the inside who want this fixed as well. So we can try.
So I feel the pain. So it's
exactly.
about creating a proper process, because like releasing an open or drivers on the Mali developer is not high priority compared to like customers who build their own drivers. So when you have a device that's officially supported by a vendor, they provide the binaries because they always need to customize and do special stuff. So we can't put those drivers on Mali developer.
Yeah. But we recognise that making our own internal development less painful is a good thing, right? So I think quite a lot of people would appreciate improvements, but it's just a matter of arranging, mechanisms, and as you say, somewhere to feedback will be, and us to discuss will be a good idea. So yeah, that's probably a good start.
Did you actually find any particular starting point for distros at all?
So the license got changed last year, so we can now redistribute the drivers even though they're still non-free. So that's a significant step, and that's good. And the lawyers started things. So now there is some point in packaging it. And like I say, I did it, but stuff doesn't work yet because we have some bits missing. And that's kind of how far I've got. So I haven't actually released anything because there wasn't much point. I didn't actually get it to show me any graphics yet on a board. When I get to that point, I'll release something. But I can stick it up anyway. I should stick it up on our Git repo, but.
I guess I'm on a similar point. So I have in our OBS a set of patches to make it compile with the latest versions of the kernel, but I haven't really tested it because the DTS bindings were until recently not yet in. But for instance, one thing that confuses me to hell is that there's like, I don't know how many dozen different tarballs are available for download, like just for one Utgard or Midgard.
Yeah, so you have drivers for Utgard, Midgard, and Bifrost. They're separate.
Or well, but even for one of those, there's like a dozen of RXPY-rel something.
That's release version. So basically,
yeah, but
taking the highest
it's nowhere
number.
documented. My point is, there's nowhere documented. Can we, as a distro, just pick the latest RXPX and be good with it, or do we need to maintain those as packages in parallel and choose them depending on like the SOC vendor or boards or whatever level?
Yeah. So normally, it's the latest driver should be picked for any of the supported hardware.
Except sometimes you drop a platform in a revision, if I understand correctly.
Yeah.
So sometimes we will need to maintain 2 revisions for a release because the platform support is built into the driver, which of course is just wrong and broken, and we need to fix that. So I mean, this whole idea, I can see why the whole design at the moment is that you build for the combination of platform, OS, device, driver, Mali hardware thingy, which produces this enormous matrix of possible builds. Yeah. And of course, for binary distributions, that's exactly what we didn't want. And we need to get away from that, but obviously that's going to take a while.
The other minor request would be if there's any way to allow for, I guess, need less updates of the old user space. So, one of the troubles that we see is that we have the old user space binaries, don't yet have new ones, can't move to the new driver. So that aspect, the dependency of that hard linking the kernel driver to the user space, if there's any way to help standardize that or minimize the number of times that's changed,
so
it would be very
on
helpful.
Utgard, that's a problem, but not on the Midgard Bifrost generation, because there you can take a newer version of the kernel driver and the old user space should be able to cope.
I'm going to go even stronger on that. Even if we had fully open source drivers, I would say the still argument applies of having not breaking old user space with new kernel updates is very, very important. If we ever want to get to the being able to support these devices with generic distributions, and up to having to keep user space in the kernel in lockstep is painful.
Yeah. No, so on Midgard and Bifrost, the latest generation of GPUs, you can actually upgrade user space or kernel space independently. So that's fixed.
And is it?
Which of the 2 parts depends on the specific board?
Okay, to be honest, you can actually build the kernel driver for Midgard/Bifrost and run it on anything. So all the GPUs released from Midgar and Bifrost can actually use the same kernel driver. The kernel driver is actually dynamically probes and sets up everything. It's only user space that actually is dependent on the GPU, because basically when the driver design was designed, okay, I led the kernel team and I did it the correct way, it seems, while someone else, because the problem in user space is that they're more depending on data structures that the GPU builds, and that has changed slightly as they fix bugs and things like that, and sometimes you need to encode data differently because of hardware bugs. And when they started to go down that route, they saw that it was too hard to actually make that dynamic, so it's all in one compiled binary and actually use switch, because the overhead of actually having a branch every time you encoded some data structure was too costly, basically, both code size but also execution performance. While in the kernel driver, there's less dependency on those kind of hardware bugs, and we've usually, the kind of hardware bugs we need to work around in the kernel driver is basically jump to a completely different handler for something. So it's basically set up a function pointer at probe time, and that's it.
But does that mean that the kernel driver knows every board, or that all the boards are similar enough that you don't have...
All the boards are similar enough, so all we need to know is basically the base address and the interrupt numbers and the clock, and we're good. Yeah, the stuff that's in the device tree, basically.
Is it possible that you will adopt Linaro 96 board support?
Well, from the Mali side, the 96 boards is nothing special. It's still every SoC is special in which GPU revision it has and how many cores it has enabled and all of that. So the binary is always compiled for the GPU revision that knows about the hardware routers, and then the shader cores. And then for fun, if you run Android, usually the customers, if you enable integration with their display hardware, it has enabled various compression standards inside the driver, which we don't even have access to. No, the high key doesn't do that, but for other boards, so that's our problem.
So I just looked, and developer.arm.com and Mali.arm.com don't actually have a feedback mechanism apart from start a support case if you're a paid customer. So that's not going to work.
Yeah,
so somebody think of another channel.
So
we should probably have
the
one.
The slides are gone, but it said Q&A and feedback, so that's useful feedback.
Exactly. So either add some chat or a mailing list or something, or think of somewhere else we can discuss.
No, but I'll make sure to mention that when I get back.
Even ARM's account managers seem to be having a difficult time finding actually someone within the Mali, department to, provide feedback to. And once they do, it kind of just seems to go into a black hole and nothing comes back again.
No, but it's definitely something I need to.
But we do have paying customers, right?
No, but it's a message I'm going to relay to my managers when I get back to see if they can do something about it. Yeah, maybe it goes into the same black hole.
Another question that I haven't checked recently, but at least sometimes it seemed that there were like newer versions of the kernel drivers available than of the user space libraries. That they were, not always in sync. That they were sometimes like two versions or something.
Yeah. So now we go back to what I mentioned, that like when you release a kernel driver, it supports everything, but we basically dropped support for some of the boards, so they've stopped updating basically pre-built binaries for some boards. So that's why you see that there's two different revisions. Say you can take the latest driver, so for the high key you can take the R7 kernel driver, the kernel driver. Yeah. 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 But for instance on Midgar you can take the R16 kernel driver and it should work with say an R14 or R12 user space.
Nordic gods, I always forget T600, which was one of gods or before gods?
Okay, so
I think that the newest Mali I have on my pile of useless Mali hardware is the Samsung Chromebook from 2012 and had 604, I think.
Yeah, that's the first generation Midgar. I know that the code names might not be meaningful, so the problem is that some customers actually use the code names and some don't, so it's hard for us even to know which actually matches between a code name and an actual marketing number.
I have an easy question for you, it's a technical one. So you mentioned some dependency between the Mali deliverables, either user space or kernel space. There's some dependency to the display controller side. So where are the dependency used? It's in user space or kernel space?
So the dependency is actually normally in Graalloc and then integration with Graalloc into EGL. So it's normally new surface descriptor formats and things like that they pass down at the Mali supports, or even and the display hardware block support. So like the user space drivers have support for many different compression formats, but the vendors only enable them based on what they actually can consume in the display and the video path. If we say, for instance, render internally for only internal use in the GPDDK, we always use the most efficient texture compression format, but if we need to render into something that's need to be scanned out, we need to make sure that we can actually scan it out, and then the customers actually do stuff, and we actually have also customers that add changes to actually support compression standards that we don't officially support in the DDK, and then they do modifications both in the hardware and in the source, and we don't have actually access to that source.
Sorry, I have a question as a graphics layman. So just want to check my understanding is right. There is a open kernel driver, but it's not going to be merged upstream because it needs the user space. Is it possible to do OpenCL with a completely open path?
No, the OpenCL driver is also is part of the commercial user space binary. So you need basically the compiler is shared between, say, Vulkan, OpenGLES, and OpenCL, the backend.
Okay. So people were saying with Vulkan, it might be less lawyer scary in terms of making an open driver. Would it be even less for OpenCL? Or?
I would say OpenCL might be on the same level as Vulkan in that regard.
Okay, but it still involves convincing lawyers.
Sorry, I have one more question. So in your DDK, you actually don't have the hardware composer implementation, right? But you have the Graalloc implementation, which depends on which inside you have the FB device support, right? Is that correct?
And so the hardware composer interface is normally part of or tightly integrated to the display side, not the GPU side. So since Mali GPU is just a GPU, we don't actually handle the actual scan-outs and say layering of multiple stuff and setting up multiple layers on the display side. That's usually customer-specific hardware.
But you do have the FB device implementation just for backwards compatibility, because in the old Android version you actually use the FB.
Yeah, but the FB is still exposed by whatever exposed the hardware composer interface. It's not part of the Mali DDK at all, because Mali doesn't do any dev FB at all.
But Android,
so the DDK can be told to actually render into say dev FB0, but it's not actually providing dev FB0. That's the display hardware on the board.
in Android, you can have the kind of configurations, don't have any hardware C implementation, but you only have the FB device. You still can running, but I'm not sure. But it seems the case. You still go use the FB instead of all the hardware composer stuff.
I'm not sure about the latest version of Android, but I know earlier versions of Android, the hardware composer was an optional component. So if you didn't have, it fell back to compositing using the GPU basically. So it combined all the layers and actually rendered into the final frame buffer. Yeah. But still, that final frame buffer was handled by something not controlled by the Mali graphics stack. Was some
that's a dependency. You only depend on the hardware FB device implementation of the vendor. Once you have that, basically you can have the display works. Right?
Yeah, so without any display hardware, the GPU would still render, but you wouldn't see anything. You can get read back what's produced and actually dump it to disk and things like that, but there's nothing to output to, because the GPU is just quite literally a 3D renderer. It doesn't actually drive any displays by itself.
And in the Graalloc, I think you have several configurations. One is use the IO as the allocate, and you have your own allocate UMP, right?
Okay, so UMP was deprecated some 5 or 6 years ago, but it's still around because some customers still use it. But ION is the preferred mechanism today, and has been for quite some years.
Okay, thank you.
Which Mali is the oldest supported?
So, so the oldest Mali, I guess, is Mali 400, because the Mali 200 doesn't exist in any devices that people have, right?
Yes, sir.
Yeah, so Mali 400 is the oldest.
Mali 300 is newer.
And Mali 300 is newer than Mali 400, by the way. So we can more say that we exclude Mali 200 and Mali 55. Okay, any final question before we head off to lunch?
Thanks for listening to our drives.
I feel, or I share of quite a few of them.
I appreciate you splitting up there.
Okay, thank you.